Hey guys, so these are your notes about atomic structure, and a lot of this is to do with isotopes as well as a little bit of atomic theory, the knowledge and history we have with the atom. So I went ahead and printed these notes out, so it's easier for me to flip through. So this is the exact same thing that you guys have on Classroom. These notes are long. I'm not going through all the details. Like I told you, this is not story time. You're not my 4-year-old. I truly believe you guys can read, and you will need to read through these to get all of the information. So I'm just focusing on some of the key pieces here. So some of the key scientists and the significant impacts that they made. So Dalton was the first one. It was Dalton's atomic theory that started it all. It brought up all these questions about an atom, how it sticks together, what an atom looks like, all of these different things. So then J.J. Thomson in 1890, he was the one that was responsible for the electron. So the electron, you should know, goes with J.J. Thomson. We talked about that in your previous notes already. He also found that an atom is balanced. So if it's an atom, the protons and electrons are equal to one another, so they have zero overall charge. Okay, so then William Thomson, also known as Lord Kelvin, in the early 1900s, he came up with the plum pudding model. So this plum pudding model, which is right here, this is what he believed the atom to look like, where it was this spherical cloud that was positive. So all of all this space in between was positive, and then you have these electrons. So plum pudding was a dessert back in England that was like this dense dessert with plums spread throughout it. So that's how he imagined it. You guys can imagine it kind of like a cookie, where these are the chocolate chips being the electrons. J.J. Thomson, by the way, this was the setup that he had. So he used something called a cathode ray tube, in which he had a stream of negative particles, the electrons. It was a gas-filled tube, and he was able to have a source of electric potential, and he discovered the electron using this. Okay, so like I said, William Thomson, Lord Kelvin, that's where we get kelvins from much later. That is where we got the plum pudding model. Then you have Ernest Rutherford. Ernest Rutherford was in 1911. He noticed that alpha particles didn't go straight through a thin piece of aluminum. So therefore, it couldn't be correct. So basically, he was trying to shoot things through this piece of aluminum, but some things were deflecting and going back off of it, which meant that there had to be some sort of positive core. So Rutherford was one who was credited with finding the nucleus. You need to know that Rutherford and the nucleus go hand to hand. That's the positive dense center of the atom. So after that, we have two more particles were found in the nucleus. In 1919, we found protons, and in 1932, we discovered our neutrons. So J.J. Thomson, electrons. Ernest Rutherford, he was responsible for the nucleus. This is a setup of Rutherford's experiment. So he was shooting some alpha particles through this piece of aluminum, but instead of going straight through, which most of them did, but instead of all of them going straight through, some of them were bounced off and deflected, and that was how he knew there had to be some sort of dense core. So this is what would have happened. So in his experiment, if this plum pudding model, which is what they had before, had been correct, it would have just all slid through. It would have gone right through because those negative particles would have just gone right on by and just slight deflections near them. But instead, what was happening was it was running into these dense cores, and those that ran into the nucleus were bounced off. So that's how they knew that the structure of the atom was different than they thought before. Okay, so that picture shows that the nucleus is basically a speck in the big atomic picture. It's really an extremely small part of the atom compared to the electron cloud, which is where all the electrons hang out. Remember again, nucleus, Rutherford, those two things go together. Do you think you might be asked to know that on a test? Again, most of an atom's volume, the space, is where the electrons are at. So the nucleus is very small in relative space to where the electron cloud is. The irony being that little speck that's in the middle that takes up the least amount of space is the most massive. The nucleus is basically the entire mass of an atom. Electrons have a very negligible weight to them. The protons and neutrons are 1,800 times the mass of that of the electrons. So if each atom is composed of these same particles, protons, neutrons, and electrons, then what makes each atom have different characteristics? In other words, which of these particles is responsible for the atom's behavior? That would be the electrons, okay? How the electrons are associated, how many it has, are going to determine how that atom is going to act. Okay, so this is the introduction of the modern concept of atomic structure. So again, Ernest Rutherford showed that the atoms have an internal structure, have some sort of nucleus in the middle. This is showing you that on the scale of 10 to the negative 13th would be how wide the nucleus would be, whereas 10 to the negative 8th would be the entire electron cloud. That nucleus has the positive center, and then neutrons being uncharged and the electrons, which are negative, move around the nucleus. This is just another structure showing you the relative weight and size of electrons to the protons and neutrons. So if an electron has a relative mass of 1, then a proton would be 1,836 times that, a neutron 1,839 times that. We know that electrons have a relative charge of -1, protons have a relative charge of +1, and neutrons have no charge. All right, I'm going to separate this into 2 separate videos. So this is the continuation of those notes of isotopes. I will start a separate video that goes over these though.